Here are the last few slides we didn't quite get to in class for chapter 4. And one of the slides we missed was about beeswax and the solubility with different types of solvents. And we remember like dissolves like, and we know that water is very polar, and this beeswax component is very nonpolar with just an ester group in the middle. So the chloroform is the least polar solvent. It's going to be the most likely to also dissolve this less polar beeswax group. We also then in between ethanol, we have a longer chain of carbon with an alcohol group. That's kind of an intermediate solubility, and the least soluble is this polar group. It's not going to want to interact with this nonpolar beeswax group. So this problem is just practicing naming a little bit more, and we covered this already in class today, but just a few more practice examples of naming. Problem 4.25, we want to do the cis 1,2-dimethyl cyclopropane. So we're thinking about cis versus trans here, and we start looking at the long chain. So cyclopropane for A, we'll do methyl, ethyl, propyl. And we also have, it's a dimethyl. So there's two methyls and it's on the same side. So we have a 1 and a 2. So we'll do a dimethyl. So we have a 1 group. And in order to show that it's on the same size, we use these wedges. And we're going to color those in. Right, so the dashes are wedges. So this is cis, it's on the same side of the ring, so we kind of use those dashes to show that methyl group coming off of there. For B, we start with a cyclopentane, so methyl, ethyl, propyl, butyl, pentyl. So this kind of looks like a house, it's a pentane. We have a 1, 2, we have a 1 ethyl, so we're going to, and also there has to be trans. So in order to show that, we're going to have to draw out that kind of dash, or that wedge structure. So that's showing it's coming out of the screen here. That's the ethyl group, the methyl group, and then the ethyl is the trans conformation. So we're going to do a dash, and we can show that in that format. So we're just showing you that this dash is attached to another group. The alternative, we could have also drawn it. It didn't really matter which was 1 or 2. Oops, sorry about that. I'll redraw this quick here. We could have had it on the wedge side, and then you can draw that line off of the wedge and then the dash too. So that's the same thing. Showing the same thing, basically just saying that this group is coming off of that ring, and it's attached to some methyl ethyl group, and then this is just a single methyl group. And it's trans because we have the dash going behind the screen and the wedge coming out of the screen. Cyclopentane. These were again earlier, and we're just looking at naming some of these compounds. So the long chain here is methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl. So we have the octane, and we're going to then name we're going to start numbering 1, 2, 3, 4, and that's a methyl group. This is on the 4 also a tert-butyl group. So the name for A is going to be 4-tert-butyl 4-methyl octane. Remember the butyl group that comes alphabetically first. For B, the long chain is actually 1, 2, 3, 4, 5, 6. So that's going to be a hexane. And we have 2 methyl groups. If we started numbering 1, 2, we have a 2 and a 4. So it's 2, 4-dimethyl hexane for that one. For C, we're going to start counting here to here. That's going to be nonane. It's 9 carbons from here to here, starting with 1, 2, 3. Again, that gives us the lowest numbers on all of our substituent groups. We have a 3-methyl and a 6-isopropyl group. So 6-isopropyl, 3-methyl nonane is going to be how that would be named and numbered. And finally for D, we're going to start, one of these two are going to be our starting number, 1 through 7 down here. So that will give us a heptane. And we have substituents on the 2 carbon and the 4 carbon. They're both methyl. So this would be 2,4-methyl heptane. So these are, again, just more naming from earlier in the chapter. A here, if sometimes it might be easier to redraw this, and you can see off of this there will be a second carbon with 2 methyl groups coming off of that. And for this one, the name is going to then be 4-ethyl 2,2-dimethyl-hexane. So the longest chain is going to be a 6-membered ring. So this is redrawn 1, 2, 3, 4, 5, and 6, and groups coming off of this carbon and 2 groups coming off of that carbon. For B, we're going to count from here. So 1, 2, 3, 4, 5, 6, 7, that's heptane. And we have substituent groups off of the 2, the 3, and the 5. So 3-ethyl-2,5-dimethylheptane should be the name for B. For C again, it might be easiest to redraw this compound. We're going to start with the CH3 on the end. And then there's 2 CH2 groups, or sorry, 3. As shown here with that 3. We have a CH, and then we have another group that is coming off on the bottom, or it doesn't matter, it's CH2, CH2, CH3, and another group CH, and a CH2, CH2 group. So these two are shown here. And the CH group is right here, and this longer parenthesis chain is shown right here. All right, so then to name this, I'm going to get rid of some of these lines. To name this, we find the longest chain, which is straight over methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, so an octane. We have a substituent group, which is an isopropyl, so 4-isopropyl octane. Since we count 1, 2, 3, 4 is the lowest number, we can give that substituent group. D, this is one of the more tricky ones. We're going to start numbering up here in this corner. Methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl. So we got a decane, which is our longest group. We have multiple substituent groups coming off of this long chain. We have a methyl group off of 2, ethyl off of 3, a sec-butyl off of 1, 2, 3, 4, 5, and we have another methyl off of the 7 carbon. So this is 5 sec-butyl, 3 ethyl, 2,7 dimethyl decane. And that concludes those questions from throughout the chapter that we had discussed in earlier slides.